Consider the situation shown in figure. Initially, the spring is unstressed when the system is released from rest. Assuming no friction in the pulley, find the maximum elongation of the spring. Okay, so initially the system was relaxed. So it is saying initially the spring is unstressed. Okay, spring is unstressed. So system is released from rest. Assuming no friction in the pulley, find maximum elongation of the spring. So how do we solve it? So initially it is unstressed. So we will use the conservation of energy here also. So object is starting from a point, and suppose it is going finally to a distance x. Finally it is going down by a distance x. Okay, so object is starting from a point, initially unstressed spring, and then going down by distance x. So what can we write? We can write the energy conservation, because there is no other forces acting. Okay, there is no loss of energy anywhere. The spring force is there and the gravitational force is there, both are conservative. So we can write delta k plus delta u spring plus delta u gravitation equal to work external, that is 0. Okay, so initially the object is released from rest, so u is 0, and finally at maximum expansion the v is again 0. At maximum expansion of the spring, the object will stop for a moment, so v will be 0. So change of kinetic energy will be what? 0, because initial final velocity both are 0. Then spring potential energy. So initially the spring is relaxed. So initially spring is relaxed, and finally suppose it is going down by x, so spring will stretch by x. So half k x square minus 1. Okay, then gravitational potential energy. So object is descending down by x, so minus mgx equal to 0. So if we solve it, we are going to get half kx square equal to mgx. So x is coming 2 mg by k. Okay, so at this point, after this much stretch, the object will stop for a moment and then it will return back. So that is the maximum x, that is the maximum expansion. So what we have to find? The maximum elongation. Okay, this is the maximum elongation. And the same question, whatever question is there in this particular problem, the same question could be like this also. Means we have a spring and we have a mass hanging, and if we release this mass from the relaxed position, if initially spring is relaxed. Okay, this question is over. I am just giving some other related question from this. Okay, so if initially the spring is relaxed, okay, and it is released from this position, so what will happen? The object will come down and it will stop for a moment and then return back. Okay, so what will be maximum elongation? Find the maximum elongation. Write the same kind of equation, and if you write same kind of equation, the initially the u is 0 and finally the v is 0. So if you write the same equation, the delta k plus delta us plus delta ug equal to work external is 0. So this delta k is 0. The change of kinetic energy initially 0, finally also 0. Spring potential energy half kx square after traveling distance x. Then gravitational potential energy minus mgx equal to 0. So x we are going to get same thing, 2 mg by k. Okay, so in this kind of questions we get answer 2 mg by k. So this is a maximum stretch, and if you compare it with the equilibrium position, so at what point we get the equilibrium, at what stretch? For equilibrium means there is no force acting. Okay, so at equilibrium, for equilibrium means no force acting. So at what point there will be no force on the object? So mg downward and kx upward. Kx naught I am writing. Okay, so x naught is how much? Mg by k. So at what stretch we get the equilibrium? At what stretch we get the zero force on the object? So that is at mg by k. But if you release the object from relaxed condition, then it travels double the distance of this equilibrium. Okay, so what is happening exactly? The object is traveling down, okay, and the gravitational force is more, and when it reaches to distance x naught, the mg by k, when it reaches to distance x naught, which is equal to mg by k, the force on it becomes 0. But by the time it reaches here, it has acquired some downward velocity, and because of that it keeps on moving further, and this time the spring force becomes more and gravity is now less. But because of the velocity, the object keeps on moving further, and finally it stops at this point, 2 mg by k. Okay, so what is happening? The object is starting from this initially relaxed position. It is going down, and then it reaches to equilibrium position where the total force is 0. But by that time it has acquired velocity and momentum, so it will move further, and it will keep on moving further to a distance 2 mg by k, and then it stops. Okay, so these two are related by a factor of 2.